So if plug in 0, it is 1. Which actually means that limit x tends to 0 negative f of x will also be 1, and limit x tends to 0 positive f of x will also be 1. There won't be any difference. And that is why I don't care when you have this value. So I don't write about these two values. I don't write these two expressions at all. This actually just means the function is continuous. If you get a different value here and a different value here, then the function is not continuous. Let's take an example. Shall I take this off the board? Right? And we'll do an example, and then that will make a lot more sense. If not 100%, 70-80% is gone in, right? I tell you, when this topic was taught to me, when I was you, 30 years ago, now you can calculate my age, it made no sense to me. Absolutely nothing. Alright, let's take an example. Let's say you have an f of x, and I need you to be writing in your notebooks, please. Please. F of x equals to x cube 5 and 6. Your f of x can take 3 different values depending upon 3 different conditions. So I'm writing the conditions now. If x is less than 1, if x equals to 1, and if x is greater than 1. Let's check whether this function is continuous at x equals to 1 or not. Right? Now, which part of the three, so this kind of a function is called a piecewise graph, right? It's called a piecewise graph because it's got different pieces, right? Or hybrid functions. You can call them hybrid functions because they take different values for different domains. These are different domains, right? Now, Romel, you tell me, out of the three values, which value is a left limit approaching from the negative side of x? X cubed. X, that's the left limit because it is approaching 1 from the negative end. X, so right, you know, if that's 1, this is approaching from here. X less than 1. Correct? Now, Ryan, which out of the 3 is the right limit?
6.
6. So that means this value, this is x greater than 1. And at 1, what is that at 1? Which value is at 1?
5.
5. Now, if I ask you, now remember, for continuity, your left limit, I'm writing A could be, A is the one here, right, where I'm checking the continuity. Your left limit should be equal to your right limit, should be equal to f of at that function. So this condition has to be satisfied, and obviously you've got f of x here, right? If this satisfies, the function is continuous. As I told you, right, your limit x tends to A has 2 parts, the negative side and the positive side. So, or if these are equal, I just write this. That's what it means. Let's check for 1, because 1 is the breakpoint here, looks like, right, and from a condition. If I approach, let's talk about the negative limit. If I approach from the left. So what I'm saying is limit x tends to 1 negative f of x. What will be f of x? Romel, what will be f of x? You plug in 1 in your left limit condition, which is your left limit domain. That's your left limit domain, correct?
Yeah.
So you plug in 1 here because you're talking about the negative side of negative limit, right? So you will say 1 cube, which is 1. Yes, Ayushka? That's your left limit. Let's try to find the right limit. Limit x tends to 1 positive f of x. Now, which condition do I need to pick up for the positive side of x, which is the right limit? Not this one. And this is just a constant. Value 6. Straight away you can see these two are not equal. It is not continuous, period. But still, let's check the final one. Add x equals to 1. Add f of 1. What is the value? When x is 1, it is 5. So you see, this graph, this function is not continuous at x equals to 1. Does that make sense?
Yeah.
Does that make sense, right? Now, if I were to quickly think about it for a second and probably draw the graph of this function, just to sort of connect the final dots, how on earth the graph will look like? Let's try to draw the graph of this function. 1 is my point, which is where I'm checking my continuity. When my x was when I was approaching from here, I would have got a cubic. Y equals to x cube. How's the graph for y equals to x cube? Right? That's the graph, correct? So I would be saying that it will be something like this. And I'll stop here. Because now it is less than 1. So I will draw an open circle here. That means it is less, 1 is not included. Right? Not slept? Still awake?
Yeah.
Okay. At x equals to 1, the value of the function is 5. So, and this would be, I'm sure this would be 1, right? You just found that. This would be 1 here. This is f of x. That's x. Ayushka, is this making sense? At x equals to 1, if it is 2, 3, 4, 5, 6. So this is 5 and this is 6. At x equals to 1, I have a closed circle. Just a closed circle because it is 5, right? The coordinate 1, 5. But beyond x equals to greater than 1, I would have a 6. 1 not included, and it is a 6. Does that make sense now? Chris?
Yeah.
Aishka?
Yeah.
Romel? Ryan? Yeah. So looking at this graph, I can now, if I just take that off from the board and I just give you this graph and I say, okay, can you tell me, is this function continuous? No, not on earth, because 1 is giving me, should have given me a 1 if I were to follow from the right, so from the left, but then no, at 1 it's giving me 5, and if I would have approached from the right side, it should have given me a 6, but no, 6 is not there. So this function has some problem, some discontinuity at 1. So again, you need to validate this in order to prove that the function is continuous. Make sense? Shall I take this off the board?
Yeah.
Yeah. Pick your notebooks out, please, and tell me whether the function that I'm now writing is continuous or not. So I'm saying my f of x equals to 2x and negative 2x plus 1, and the conditions are, this is if x is greater than or equal to 0 and if x is less than 0. Can you tell me, is this function continuous at x equals to 0? Let's check the answers. I need to validate the left limit. So my left limit is that limit. So I will say limit, if it's a 2-mark question, x tends to 0 negative, f of x is negative 2 times 0 plus 1, which is 1. And then I say limit, x tends to 0 positive, f of x equals to 2 times 0, which is this value, equals to 0 straight away. But then I will also say what is f of 0 at 0. You see, this is equal to sign. He's not giving you third condition. He's just plugged the two conditions into one. So again, there will be 2x, which is 2 times 0 is 0. So where your right limit and your at that point you got the same value. Problematic was the left limit, which gave you a different answer. And hence you say this is how exactly you will write. You have to show this to get 2 marks. Right? 1 mark question, you can say, okay, discontinuity at 0, 0, they don't care about it. Right? So you'll say therefore, the function is discontinuous at x equals to 0. Right? Make sense? Absolutely? No dramas there? Alright, let's do a graph question quickly. Now this question was, the question that we did now was the algebraic form of the question of the limits. You can also do very similar kind of question where you could be just given this. For example, this. And you were to say that, okay, tell me, but then I'll draw one. This is 1. Obviously, this is x. This is f of x. And this is, let's say, this is, let's say 3. And then and one more thing. Tell me, is this function continuous?
No.
No, straight away. Why? Because your left limit, your f of x from limit x tends to negative side is basically 3, right? It's 3, approaching 3. Even your right limit here also approaches 3. This is not equal, this is the limiting value. At x tends to 1 positive, f of x is 3. But what is f of 1? F of 1 is 5. That's the problem. And that means the function is not continuous. Does that make sense, guys? Yes? Right? Rumel, yes? Makes sense. Shall I take this off the board? You're fine, Aishka? Let's now quickly connect differentiability, and that's the last topic in the game for chapter 9, which is the differentiation. And then we'll jump on to tangents and normals. I'll take this off as well. We'll talk about the differentiability. When is a function differentiable? When can you differentiate a function? So differentiable. So far, what we've learned is that, okay, I'll give you any f of x in the world, you can differentiate it, right? You know the rules, right? Product rule, chain rule, quotient rule, x, y, z, right? You can do that. But there is a basis behind what can be differentiated and what cannot be. And that basis is continuity. Only continuous functions can be differentiated. If a function is not continuous at a point, then the function is not differentiable at that point, right? So what does that mean? It says a function is said to be differentiable at x equals to a. I can differentiate a function at x equals to a if limit x tends to a of f of a plus h minus f of a over a plus h exists. You remember the first principle, right? So this is the first principle. This is the first principle. Now let's take an example. So if I say, let's say my f of x is x and minus x if x is greater than or equal to 0 and if x is less than 0. Is this function differentiable at x equals to 0? Check the continuity. If the function is not continuous, say no. Yes, Ayushka? So if I check the continuity at x equals to 0, f of 0 is 0. That's the one, greater than equal to. Now, Chris, f of x, my negative limit, is this value?
Yep.
So what is that value? So what will that give me?
0.
0? Oh, I think I messed up. Let's take it x squared plus 2x, and I'll come back to what I just left, right? And this is 2x plus 1. You've got this function. The top condition is when your x is greater than or equal to 0, and the bottom condition is when your x is less than or equal to 0. Now, if I were to find whether this function is differentiable at x equals to 0 or not, so the first things first you will do is you find the differential of this function. So differential of this will be 2x plus 2. Condition was x greater than 0. And then for this one, it was 2 for x less than 0. Now you check the continuity at x equals to 0. Now let's check the continuity at x equals to 0. So if I plug in the left limit, the answer is 2. If I plug in the right limit, the answer is 2 again, right? So that means this function, and if I plug in x equals to 0, obviously it will be 2 again. So plug in x equals to 0 again, you're left with 2. This value, x is less than 0, 2, greater than 0 is 2, right? So this function is f dash x. So this function is differentiable at x equals to 0. Again, now come back to the basics. Differentiability. So what is this? That is the first principle of differentiation. First principle of differentiation. So if I were to now shortcut it and explain you and tell you, if someone asks you in the exam, given the f of x, so you could have two type of questions. One is, you'll be given f of x and you'll say whether this function is continuous at x equals to 0 or not. Then you check this value. But if it says check whether the function is differentiable at x equals to 0 or not, then you find the differential of the functions and then check the continuity. Because we are checking the continuity of the differential, right? So if the differential is not continuous, the function is not continuous. So how will I draw the graph of this function? 2x plus 2. So that means this will be 2, and then this is f dash x, and this is x. You see, this function is a clean flow, right? It's no breakpoint. Does that make sense? Now coming back to what I was trying to explain earlier, and I said, I'll better explain with a different example, is my example was f of x equals to x and minus x for x greater than 0, x less than 0. This function is continuous. This function is continuous at x equals to 0. If you see that, right limit, left limit, plug in 0, which is minus 0 is 0. So this is the left limit. Right limit, plug in x equals to 0, so you get x as 0, you get a 0. And at f of 0, it is 0. So yes, this function is bang continuous at x equals to 0. But now if I ask you, can you tell me whether this function is differentiable at x equals to 0 or not? Then what you will do is you will go one step further and you will differentiate these two functions. So you'll say, okay, f dash x for x is 1 and for negative x is minus 1. X greater than 0 equal to and x less than 0. Now can you tell me whether this function is differentiable at x equals to 0? Anushka? No, correct. Chris, yes? Because at x equal, from the left side it is minus 1, from the right side it is 1. So though this function is continuous at x equals to 0, you still cannot differentiate it. It's not differentiable at x equals to 0. Make sense?
Yeah.
Yeah?
How do you know, like, whether they want you to do it with the differentiation or
They will ask you the question like, for the function, for the given function, we'll give you the function,
Yeah.
for the rule, find the f dash x. and prove that the function is differentiable or
Okay.
not. Or find f dash x and draw the graph. That does not harm continuity then. Right? You just do the f dash x like this and you just do the graph.
Okay.
Right? So they'll talk about it. Right? Or they will say, tell me with this function, the derivative is defined at x equals to 0 here or not. So when they say derivative is defined at, function is differentiable at, then you find the differential and then check the continuity. And when they simply say, okay, you've given the function, check the continuity, then there's no point of differentiating. That's the difference. Right? Make sense?
Yeah.
Yes? F of x equals to let's say x raised to the power of negative 2 over 3. Yes, any thoughts? How will you draw the graph of this one? What will be the graph? Anushka, any thoughts?
Is it
Nothing?
without cas?
Without CAS, with your knowledge of how the graphs have to be drawn. Whenever you see negative indices, first of all, convert it into positive index. Always, always. So can I write it like this? Yes?
Yeah.
Laws of indices. Yes, Romel? Then, can I write it like this? 1 over x 1 by 3 square. Yes?
Mhm.
Yeah.
Let's say 1 over x over 1 by 3 is u. So how will this graph look like?
Is it a truncus?
Truncus, finish, period. That's it. I don't care about that root there. Does it make sense? Yes?
Yeah.
I don't care about it. This is a truncus. Right? So at times, you can be thrown something like this. Right? Basics needs to be absolutely clear. I think we're done with chapter 9 now. And what's the time by the watch right now? We've got 10 minutes. What is a differential? What is a differential? Who can explain me that? Chris.
Is
I'll ask each one of you. What is differential?
the gradient of a graph?
Gradient of the graph, is it? Gradient is fine, off the graph is wrong. Remember,
It's the gradient at a point. Like,
at the point? Where?
where's tangent? Like, oh yeah.
Halfway through now. Gradient at a point.
It's the gradient of the tangent at a point on the graph.
Awesome. 100% right. Right? So, Ryan, if you missed it. So, for example, if I have a curve like this, let's say, right? I have to find the differential at this point, at this point, and at this point. Then what do I do? So at this point, at this point and at this point. This is the curve. This is f of x. And this is x. So wherever I'm trying to find the gradient, at that point I will draw a tangent. Tangent is the line which touches the graph at one point. So here also I can draw a tangent, and here also I can draw a tangent. Then I find the rise over run of this tangent, the tan theta of this tangent. So if this is theta, I find the tan theta rise over run for this tangent. Then I don't have to do anything with the graph. I'm just dealing with the tangent. And that value of tan theta is the gradient. Why am I using tan theta? Because what is tan theta? So, ka, toa. Theta, opposite over adjacent. Rise over run. And what is gradient? Rise over run. So gradient is also the tan theta. Right? So don't get confused. If someone says find the tan theta, someone gives you theta value and say, okay, find the gradient, find the differential. Tan theta, finish. Right? We'll do questions like these. So what do you reckon? This line here would, I don't have the dimensions, but the gradient must be positive. Positive value. It's going like this. Yes, Ayushka? Yes, right? What's the gradient here? When the line becomes parallel to x-axis, the gradient is 0. So my gradient or my slope is 0 for this tangent. So gradient of the tangent on a point on the graph is 0. That means differential is 0. Right? Similarly here, the differential will be negative. Right. Then there's a concept of normals. Have you heard about normal? Tangents and normals?
Is there like a perpendicular?
Exactly. So if I give you a very layman example of circle, and let's say if you've got a tangent at the point here on the circle, then the normal is the perpendicular drawn from the center to the point where the tangent is drawn. So the tangent and the normals are perpendicular to each other. So normal is, this is the line, this is the geometrical symbol of perpendicular. That means that they make 90-degree angle with each other. So the differential, now hear me out loud and clear. So the differential of the normal or the gradient of the normal, because that's one and the same thing, is always 1 over the gradient of the tangent. Why? Because when the two lines are perpendicular to each other with slope m1 and m2, the product is always -1. So if m2 is the gradient of the normal and m1 is the gradient or derivative of the tangent, that's m2 and that's m1. I just rearrange this formula. You could be asked to find the gradient or the derivative at a point. That means the gradient of this tangent at a point, and then you will ask, okay, I don't care about this gradient, or I don't care about this tangent. Find me the normal. This line. Find me the equation of this line. And then you will use this rule. So you find the derivative at that point. You then invert it with a negative, reciprocate it with a negative. So now you have the gradient of the normal and then you will apply y equals to mx plus c, the line, equation of the line, to find the equation of the normal. Does that make sense? If I ask you that I have a graph y equals to, write it down, y equals to x cubed plus half x square, can you find the equation of the tangent? Equation of the tangent at x equals to 1. I'm not dealing with normal. Just find me the equation of the tangent line that you will draw at the point x equals to 1 for this graph. Quick. Think about it. What will be the first step here? What will be the first step here?
Differentiate.
Differentiate the function so that you get the slope, the expression of the slope. So differential would be 3x square plus, this is x is for minus 2, right? So have minus 2 x is power of minus 3. Correct? And then since you're finding at x equals to 1, plug x equals to 1 in and find a value. That is the gradient of the tangent. The value of the gradient of the tangent. Right? Yes or no? Right? And then, obviously you don't have the intercepts, then you've got another equation of the line which is y minus y1 equals to equals to m times x minus x1. You can use this equation as well. You need to be handy with these. Now what is x1, y1? Any point on the graph. So this, at x equals to 1, if you plug in x equals to 1 here, you get the y value on the graph. You use that to plug in here and you've got the value of m anyway. Plug that in, you get your answer. I'll stop here and we'll continue chapter 10 next week.